T1, that its chainage becomes the whole number of the chains, that is the whole number of peg interval. The length of the first sub-chord is thus less than the peg interval, and it is generally called as a sub-chord. Similarly, there will be a sub-chord at the end of the curve. So, we will having two sub-chord, one at the beginning and one at the last. So, thus a curve usually consists of two sub-chords and a number of full chords of 30 meter each. So, now we have an example to calculate how we calculate various elements of the curve. So, problem is a simple circular curve is to have a radius of 573 meters and the tangent intersect at a chainage of 1060 meter. This is the chainage of the intersection point, and the angle of intersection I is 120 degree. Find tangent distance, second chainage at the beginning and at the end of the curve, length of the curve, length of the long chord, degree of the curve, number of full and sub chords. So, we have just seen the figure. The deflection angle is 180 degree minus intersection angle 120 degree. So, we calculate deflection angle is equal to 60 degree. Next is radius given 173 meter. This is the figure. In figure, chainage of the intersection point, please see on your meter screen. This is 1060 meter. This is the angle of intersection, and we have calculated 60 degree as a deflection angle. So, tangent length we can calculate by using formula r tan phi by 2. So, that is r is 573 meters and tan 30 meter. So, it comes out to be 330.85 meter, first answer. So, for calculating length of curve, we use formula pi r phi by 180 degree. So, r is 573, phi is 60 degree, and the answer comes out to be 600 meter. So, that is length of the curve is 600 meter. So, chainage of first tangent point T1, how we calculate it? Chainage of intersection point B is given as 1060 meter minus tangent length we have just calculated 330.85. So, after calculating, the chainage of first tangent point will be 729.15. So, in this way we have calculated the second answer, that is the chainage of the first tangent point T1. So, third one is the length of the long chord. So, the formula for the calculating length of long chord is 2 r sin phi by 2. R is 573 meters and phi is 30 degree, 60 degree. So, phi by 2 becomes 30 degree, and we have calculated as 573 meter is equal to length of long chord, which is the answer number 3. So, for calculating degree of curve, we have just found out the relation between radius and degree of curve as r is equal to 1719 divided by d. So, we know r as 573 meter. So, d will comes out to be 1719 divided by 573, it comes out to be 3 degree. So, the degree of curve will be 3 degree. So, answer number 5, for calculating number 5, number of full and sub chord, I require your attention. So, assuming peg interval as 30 meter, that is we generally keep peg interval as 30 meter. So, we have just calculated the chainage of T1 as 729.15 meter, and we will convert this chainage into chain lengths divided by 30. So, it will become 24 full chain lengths of 30 meter plus 9.15 meter. So, chainage of first peg on the curve should be 25 full chain lengths, and to make it we will calculate we will subtract from 25 full chains minus 24 plus 9.15, and we will calculate the length of first sub chord as 20.85 meter. That is, this is the length of first sub chord. Now, we have chainage of T2 as 1329.15 divided by 30, this number of chain lengths of 30 meter each. So, it will be 44 full chain lengths plus 9.15 meter. So, chainage of last peg on the curve is 44 chains. So, last sub chord becomes 9.15 meter, answer number 5. So, we have number of full chords as chainage of last peg minus chainage of first peg. So, 44 minus 25 and this comes out to be 19. So, there will be 19 full chords of 30 meter and 2 sub chords we have just calculated. So, we can check it, length of full chords 19 multiplied by 30, that becomes 570.00 meter. Length of first sub chord we have just calculated 20.85 meter and length of last sub chord as 9.15 meter. So, when we will add all these figures, so this comes out to be exactly 600.00 meter, which is same as the length of the curve, and we find our calculations are correct. So, in this way we can calculate various elements of the curve as is given in the numerical problem. So, we have linear methods of setting out curves. We have following linear methods: offset from tangents, and second is by successive bisection of arcs, third one is by offsets from chords produced. So, first method is by offset from tangents. When the deflection angle and the radius of the curve both are small, the curves are set out by offsets from the tangents. So, offsets are set out either radially or perpendicular to the tangents according as the center of the curve is accessible or inaccessible. So, this is the figure showing radial offsets. So, offset for calculating offset, a formula is given: OX is equal to r square plus x square under root minus r. So, this is the exact relation. When the radius is large, the offsets may be calculated by the approximate formula, which is as under. First, we have the exact relation, and what is the approximate relation? OX is equal to x square divided by 2r when the radius is large, and the offsets may be calculated by the approximate formula, which is x square by 2r. So, second is by offset perpendicular to the tangent as is shown on the monitor screen. So, formula for this is exact relation: OX is equal to r minus under the root r square minus x square. This is exact relation, and for approximate relation OX is equal to x square by 2r. Next is by offset from the tangents. Locate the tangent points T1 and T2, measure equal distances, say 15 or 30 meter along the tangent from T1. Third, set out the offset calculated by any of the above methods we have just studied at each distance, thus obtaining the required points on the curve. Continue the process until the apex of the curve is reached. Set out the other half of the curve from second tangent. This method is suitable for setting out sharp curves where the ground outside the curve is favorable for chaining. So, we have a numerical problem: calculate the offsets at 20 meter intervals along the tangents to locate a curve having a radius of 400 meter, the deflection angle being 60 degree. So, how we solve it? Which is given radius of the curve is 400 meter, deflection angle is given as 60 degree. So, tangent length becomes by the formula r tan phi by 2 400 is radius tan 60 degree by 2. So, by using the exact method we have OX. When we fill the values, O20 is 0.5 meter, O40 as 2.00 meter, O60 as 4.47 meter, O80 as 7.92 meters and O100 as 12.31 method. So, in this way we have calculated the various offsets. Similarly, by perpendicular offsets we can find out various offsets by using the relation OX is equal to R minus R square minus x square under the root. So, this is the exact method, and we by filling the values we have just in our numerical problem value of OX as 20, 40, 60, 80 and 100 meter, and the radius R is given as is given in our problem. Radius is 400 meter. So, by putting values x here as 20 meter, radius as 400 meter. So, we have calculated over 20 as 400 square minus 20 square, and the value of offset at O20 comes out to be 0.5 meter, and O40 fill out the values. R is equal to 400 and offset as x as 40. So, that comes out to be 2.00 meter, and value of offset at 60 meter interval. R is equal to 400 meter and x value of x is 60 meter. So, that value comes out to be 4.53 meter, that is value of offset at 60 meter comes out to be 4.53 meter, and value of O80 R as 400 meter and x as 80 meter. When we will fill these values, and we have calculated as 8.08 meter. Similarly, we can find out the value of the offset at 100 meters by filling the values of radius as 400 meter, R as 400 meters and x as 100 meter. So, the value of the offset at 100 meter comes out to be 12.7 meter. So, in this way we will calculate value of the offset by using exact method and approximate method. In this way we have calculated the perpendicular offset by using exact method as offset from O20 as 0.5 meter, O40 as 2 meter, O60 as 4.53 meter, O80 as 8.08 meter, O100 as 12.7 meter. Similarly, by approximate formula, which is OX is equal to x square divided by 2R, we can find out the values of the offset for 20 meter, 40 meter, 60 meter, 80 meter and 100 meter and so on. And in this way we can calculate various offset and join all these pegs to find out the curve laid out on the ground. So, this is all about the curves for today's lecture, and I hope you must have enjoyed the session. Thank you very much.